Good evening, everyone. So, welcome to Career Launcher. My name is Naveen, and today we will be looking at maths practice questions, and this is part 5 of the series. So, we'll be looking at some of the very good questions in mathematics that has come in the recent years. Okay, basically the questions, which are of new types as compared to what it has been asked in the last decade. Recent years, in the last couple of years, we have seen that maths questions have become kind of difficult problems. Okay, so we'll be looking at those problems. We will see how to solve them, and the questions are going to revolve around the topic numbers. Okay, so let's look at the first question. How many pairs of natural numbers are there such that the difference between whose squares is 63? So basically, we are told that we need pairs, as in two natural numbers. Let's say one of them is A and the other is B. Then we need to calculate the squares difference. So difference of the squares. That means A square minus B square is going to be 63. Now, A square minus B square can be written as A minus B into A plus B, that is equal to 63. Now, the thing is, if A and B are natural numbers, their difference and their sum, they both are going to be natural numbers, which basically means we need to find out in how many ways we can write 63 as product of two numbers. So 63 can be written as 1 into 63. So that's one way. Next, it can be written as 3 into 21. That's the second way. Next, it can be written as 7 into 9. That's the third way. Now, the moment we go beyond 7 and say it can also be written as 9 into 7, now the thing is, A minus B is always going to be less than A plus B, given that A and B are natural numbers. Now, A minus B cannot be negative, because if A minus B is negative, A plus B will be positive. Their product will be negative. But 63 is not a negative number. So it is understood that A is going to be greater than B, such that A minus B is going to be less than A plus B. So there are three cases where this is going to happen. Now, the thing is, it is not mandatory for us to figure out the values of A and B for which this will be true. But in case, let's say if you wish to figure out, then we can write A minus B is equal to 1, A plus B is equal to 63. If we solve this, we will have A is equal to 32 and B is equal to 31. So 32 square minus 31 square is going to be 63. Next, A minus B is equal to 3 and A plus B is equal to 21. If we solve this, we will get the value of A is equal to 12 and that of B is going to be equal to 9. 12 square minus 9 square, 144 minus 81 is also 63. Next, third scenario, A minus B is going to be 7 and A plus B is going to be 9. If you solve this, we will be getting A is equal to 8 and B is going to be 1. 8 square is 64. 64 minus 1 square is 1. So 64 minus 1 is also 63. So these are the three sets of values of A, B that gives us the answer for the given condition. Right? So basically it looks to be difficult because we do not know which two numbers squares difference is going to be 63. But if you proceed with the standard way, whatever is written, if we start from there, we realize that it eventually boils down to something which is simple. Let's look at the next question. What is the smallest number greater than 1000 that when divided by any one of the numbers 6, 9, 12, 15, 18 leaves a remainder of 3? Since we are asked smallest number and greater than 1000, so what we will do is we will not solve it using the general way. We will use options. So the first option, which is the smallest, is 1063. Now, if we take 1063 and if we divide it by 6, we should get a remainder of 3. Let's see if that happens or not. So 1063, 1 times 6, subtract 46, 7 times 42, 4, 6 times, sorry, 7 times again, 42, and the remainder we get is 1. So 1063 is not the answer. Let's check 1073. 1073 when divided by 6, 1 times, so we will have 47. So this will go 7 times, so this is 52. 5 is the difference, then 53. 8 into 6 is 48. If we subtract, we get 5 as the remainder, not 3. B is also not our answer. Now, let's look at 1083. Now, the thing is, if we divide a number by 6 or 12 or 9, and if we get a remainder of 3, then with 18 also it will give us a remainder of 3, because 18 is the LCM of 6, 9 both, right? And if from 12 we get a remainder of 3, that would mean with 6 also we'll get a remainder of 3. So basically we should check for 18, right? But what 18 table we are not very much going to be comfortable with, right? So if you're comfortable with the table of 18, great. If you're not comfortable with table of 18 and 12, then you should always start with 6. So let's start with 18. If you take 18 and divide, so 18 into 6 is 108. 3 is the remainder. So with 18, if we get the remainder as 3, then from 6 and 9 also we'll get the remainder as 3. Now our turn is to check with 12. So 1083. And if we, sorry, this was 18 and not 6. If we divide it by 12, so 12 into 9 is 108, and we get the remainder as 3. So from 12 also we get the remainder as 3. Now the last one, 15. So if we take 1083 and divide it by 15, so this is going to be 15 into 7 is 105. Then we are left with 33 if we subtract. 15 into 2 is 30, and we get the remainder as 3. So from 15 as well, we get the remainder as 3. So the answer is going to be option C. If option C was not the answer, then obviously D was the answer. We do not have to check for D. Next, how many zeros are at the end of the result of 1 into 5 into 10 into 15 into 20 and so on up to 60? So basically, we get zeros at the end, also known as trailing zeros, that accounts for, so we can write number of trailing zeros is going to be same as the number of tens, and the number of tens have to do with number of 2s into 5s. Basically, number of 2 into 5s. So each 1, 2 and 1, 5 will generate a 10, right? So if you look at this particular problem, this 1 is of no concern to us because 1 doesn't have a 2 or a 5. So if you look at the first one, first term, it's 5 into 1. 10 is 5 into 2. 15 is 5 into 3. 20 is 5 into 4. 25 is 5 into 5. 30 is 5 into 6. And so on. 60 is 5 into 12. Now, if we look here, the number of times 5s are getting multiplied is the number of times we are going to have the brackets. So in case of 5 into 5, I am not going to take the other 5. I'm only concerned with picking only one 5 from each bracket. Okay. So this is going to give us 5 is getting multiplied 12 times because we can see that there are 12 brackets here. So we will be getting 5 raised to 12 into, we'll be left with 1, 2, 3, 4, and so on up to 12. That is getting multiplied. So 1 into 2 into 3 and so on up to 12. Now, the product of all the numbers from 1 to 12 is nothing but 12 factorial. So we get 5 to the power 12 into 12 factorial. Now, it is rather easy to calculate the number of a prime number, whether it is a 2 or a 5 or in some cases 3 or 7. if we are given a numbers factorial. So in the case of 12 factorial, number of 2's is going to be, how do we calculate it? We pick this number and divide by 2. So 12 by 2 is going to be 6. Then we pick this 6 and divide it by 2. That's going to give us 3. Then we pick 3 and divide it by 2. It's going to give us 1. And then we add all those quotients. So we will be getting a total of 10 2's. So 12 factorial has 10 2's. Now, should we check the number of 5's as well? Not really. The thing is, we have 12 5's here and only 10 2's. So when they multiply, only 10 pairs we can have. So we can only have 2 into 5 raised to 10, which means we can only have 10 trailing zeros. So the answer is going to be 10, option A. Right? Another problem. What is the sum of all digits which appear in all the integers from 10 to 100? So basically, if we write from 10 to 19, what will happen is 1 is written at the tens place 10 times. And then at the units place, we have 1 to 9 written. 0 is also there, but since we have to add all the digits, 0 will not be an issue, right? So the sum of all the digits is going to be 1 is going to be written 10 times. And then we will have the numbers from 1 to 9, right? Now, if we talk from 20 to 29, here at the tens place, 2 will be written again 10 times. While at the units place, we will have again 1 to 9. Again, it's going to be zeros. We are going to have a 0 also from 20 ka 0, but 0 is not going to add to give us anything. So I'm going to skip zeros. So this is going to be, 2 is going to be written 10 times. And then we will have this sum of the numbers from 1 to 9 as well. If we continue like this, finally we will have 91 to 99. That's the last 10 numbers. So at the tens place, 9 will be written how many times? Again 10 times. While at the units place, we will have 1 to 9 again written, 91, 92's 2, 93's 3, and so on up to 99's units place 9. So that means now 9 is going to be written 10 times. And then we will also have sum of all the digits from 1 to 9. And also in the number 100, we have 1 plus 0 plus 0. So we will be adding 1 more to whatever answer we get from here. Now, what is the sum of all these numbers? So basically 1 to 9, each digit is written 9 times. Then 1 is again written 9 times. So basically 1 is getting added 9 times, sorry, 1 is getting added 10 times there and then 9 times here. So that's going to be 19 times. Next, 2 is getting added 10 times here and then 2 is going to be added 10 times again. So that's 19 times. Similarly, 9 is getting added 10 times here and then 9 times here as well. So that's going to be 9 into 19 and then we will also have a 1. So basically, if you look at this, we can take out 19 outside. We are to take 1 to 9 sum and then we also need to have 1. Now, sum of all the natural numbers from 1 to n is given as n into n plus 1 whole divided by 2. And let's not forget 1 that we are supposed to get from the number 100, 1 plus 0 plus 0. So this is going to be 19. 9 into 10 is 90 by 2. That's going to be 45. And then 1 more. Now, should we actually solve what is 19 into 45? No. 9 into 5 is going to be a number that will end in 5. 9 into 5 is 45, right? And then when we add 1 to it, my final answer will have a units place, which is going to be 6. There is only one option that has the units digit as 6. Now, the thing is, why did I choose to look at only units place and not calculate the entire thing? Because I glanced through the options and I saw that each option has got a unique last digit. So if the units digit turned out to be 0, it could be only C option. If the units digit turned out to be 1, it could only be D option. And had the units digit turned out to be 5, there was only option A possible. Because I had unique digits in the options, I chose not to calculate everything but only looked at the units place. Right? Smart move, saved us a lot of time and did not have to do the calculations. Next problem. In a group of 15 people, 7 can read French, 8 can read English, while 3 of them can read neither of these two languages. The number of people who can read exactly one language is. So we draw a boundary. So this is a set theory Venn diagram based question. So in this group, we have got 15 people. So we'll write down 15 outside. Then let's take the red circle for French people where there are 7 of them. Then let's take the blue circle for English. And for English, we have got 8 of them. And then the question says 3 of them can read neither of the two languages. So these are the people who can read only French. These are the people who can read French and English both. These are the people who can read only English. These are the people who can read neither English nor French. This is what 3 is going to be. Now the question asked is number of people who can read exactly one language. So what I'm going to do is I'm going to consider this to be X. Now if I look at the red circle, that's the French one. That circle or that set's overall sum should be 7, out of which we already have X. So this is supposed to be 7 minus X, such that 7 minus X plus X will result in 7. Now let's look at the blue circle. Inside the blue circle, we already have X. We need the overall sum to be 8. So this is supposed to be 8 minus X, because 8 minus X plus X is going to give us 8. Now, as per the diagram and as per the question, 7 minus X plus 8 minus X plus 3 is going to be 15. If you solve this, 7 plus 8, 15 plus 3, 18, minus X plus X minus X is equal to 15. So we will get the value of X is equal to 3, 18 minus 15. If X is going to be equal to 3, that means 7 minus X will be 4 and 8 minus X will be 5. So that means the number of people who can read exactly one language, as in people who can read only French and the people who can read only English, it's going to be 4 plus 5, which will result in 9. 9, C option. This can also be solved using De Morgan's theorem. It completely depends if you are aware of that. Otherwise, Venn diagram is an approach which will always help, irrespective of whether we are solving a 2-set Venn diagram, whether we are solving a 3-set Venn diagram, whether a lot of information is given, whether very few information is given. Question number 6. What is the remainder if 2 raised to 192 is divided by 6? Well, I do not know what 2 raised to 192 value is, and I do not know for sure that when it is divided by 6, what is the remainder. So what I will do is I will try to find a pattern. So when I take 2 and divide it by 6, the remainder is going to be 2. In case if you did not know how I got this, when you take 2 and divide it by 6, it will go 0 times and the remainder is going to be 2. Right? Next, 2 square, that is 4. 4 when divided by 6, I'll have the remainder as 4. So we will have 2 square, that is 4. When divided by 6, it will go 0 times and the remainder will be 4. Now 2 cubed, that is 8, when divided by 6, remainder is going to be 2. So 8 when divided by 6, it will go 1 times and the remainder will be 2. 2 to the power 4, 16 when divided by 6, the remainder will be 4. So if we take 16 and divide it by 6, sorry. So 6 into 2, 12, 16 minus 12 is 4. And this will continue. If you look at the pattern, the answer is 2, 4. It's again 2. It's again 4. So that means the answer is going to be 2 or 4, one of these two. Now, that is one cyclicity. That's one cycle that is happening. 2, 4, 2, 4, 2, 4. It continues. Now, if you look at what power I get a 2 and at what power I get a 4, so I see that whenever the power of 2 is odd and when I divide it by 6, I get the remainder as 2. And whenever 2 has an even power and when I divide it by 6, I always get a remainder of 4. This is true here as well. This is true here as well. So this is the pattern I get. Well, I have an even power. That means I should get 4 as the remainder. So questions based on remainders, this is how we should solve when the values are given as powers. When you are given values where different numbers when divided by different values and you get a remainder, then what you do is you start with the options or you calculate the LCM of the divisors, like how we solve it in question number 2. Then when it comes to factorials, this is how you calculate the number of any prime number. When you are calculating sum of digits or how many times a digit appears, there has to be a pattern. So patiently see at units place what is happening. At that time, completely ignore the tens digit. And when you are paying attention to tens digit, completely ignore the units digit. Venn diagram based questions, set theory based questions. One of the best ways to go about this is using Venn diagram. If you practice enough, you can be very, very quick. Well, that's all for today. If you guys have any question, feel free to ask. Okay. Either you can ask in the comment section or you can ask in the chat. I'll reply to your queries. Okay. The moment I see them. Okay. Feel free to share your doubts and whatever queries you have. Okay. Thank you for watching. Please make sure that you subscribe to the channel, like the video, and share it with your friends. Thank you. Thank you once again. I'll see you again very soon with another session. Until then, take care.